Have y'all heard of the Cesàro sum before? If not, it's a pretty interesting way of potentially dealing with certain divergent series. The Cesàro sum, or the Cesàro mean, is defined as the value of the limit as n goes to infinity of the sequence of the arithmetic means of the first n partial sums of your series. For example, let's take Grandi's series. We all know that it's a divergent series, right? Because the sequence of its partial sums, which are all just ones and zeros, will diverge. But now let's try to apply the Cesàro sum to Grandi's series. Doing so, we get the following sequence. First, we get 1 over 1, which is 1. Then we get 1 plus 0 over 2, which is 1/2. Then we get 1 plus 0 plus 1 over 3, which is 2/3, and on it goes. But you can see that this sequence is tending towards 1/2. So that means the Cesàro sum of Grandi's series is 1/2. That may seem a little bit strange, actually, because if you think about it, that means we're claiming that 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on forever, equals to 1/2. Such is the nature of divergent series. Now, not all divergent series will have a Cesàro sum. For example, let's consider the sum of the natural numbers. Attempting to apply the Cesàro sum to this series will not work because, as you can see, the sequence of the arithmetic means of the first n partial sums will diverge. But of course, there's a sense in which we can still assign a value to this particular series. Cesàro, Cesàro. I am not sure how to pronounce that name, but I'm pretty sure one of the first two is the English pronunciation and the last one is the Italian pronunciation. And I probably switched between different pronunciations throughout this video, so my apologies for that.